Welcome to the further demonstration of smart zone based vehicle speed controlling system. So in this project, to mention the smart zone, so we are going to making use of RF. So this is a RF transmitter. So in real time it's going to be the 500 meters or 1 kilometer or 2 kilometers based on the transmitting power. We can define the location area, like a diameter of that location, and till the diameter it will transmit the information. And whenever the external vehicle which has the RF receiver entered into the region, then the microcontroller will capture the data received from this RF receiver and display on the LCD. We are entering into the respective zone, like a school or hospital zone. So in that zone, so we have restricted the vehicle speed to the 45 kilometers per hour or 30 kilometers per hour. So whenever the user trying to increase the vehicle speed by this throttle, so this potentiometer is acting as a throttle, nothing but accelerator. So when you increase the speed, then the system will check the whether it's a normal zone or a restricted zone. So in the restricted zone, if you increase the speed above the 45 kilometers per hour, then it will inform to the user by on the LED and the message on the LCD, like reduce the speed. So the 5 times warning message will be displayed on the LCD screen. So after that also is keep on going with the high speed in that region zone. Then the system will send the message alert to the authorities mentioning the vehicle number along with which zone he is crossed the speed limit. So like this message we are going to receive from the system. So for SMS sending purpose, we are going to making use of SIM A9 module, and we should insert a micro SIM card into this, and we should have the like message balance or SMS balance. And the main important thing is we should use Airtel or VI or BSNL other than the Jio, because Jio is a not 4G, it's a LTE SIM card, so that the GSM modem can't get the signal from that LTE SIM card. So here we interface this potentiometer at A0 for increasing and decreasing the set speed, and a GSM module at B0, B1, and LCD at pin number B2 to B7, and C2 pin is connected to the vehicle speed regulation purpose, that was to the MOSFET driver. So here using IRF 540 MOSFET driver to regulate the speed of the DC motors. So the back side of this robot vehicle, so we have attached 2 DC motors that will be control the we are going to control the speed of the motors with the help of this IRF Z004 by using the PWM signals. And the whole system driven by the 12 volt 1 amp battery. So here using this 12 volt 1 amp battery, as a battery pack consists of 3 4 volt 1 amp batteries are connected in series, which is rechargeable battery. So in order to recharge that battery, just by making use of this charging circuitry, we can charge. So there we wrote the B to the B over here, disconnect it from the motherboard and connect it at the same B slot. So we have the B here and keep it aside like this, and the next provide the 230 volts input to the system. So the transformer will step down the 230 volts AC to 12 volts AC, and this regulated power supply board will convert the AC to DC and pure DC with the help of this smoothing capacitor. That smooth after that we'll get the 12 volts, which is sufficient to charge the battery. So it will be fully charged in a duration of 8 hours maximum. So once the time completes, automatically these diodes block the power current from the charger to the battery. So then just you can disconnect the battery and you can switch off the charger. And then this is the main on off switch which is on the motherboard. So this is going to be the main on off switch. So reconnect the back B to the B. Okay, and the next step is insert a valid SIM card, as we discussed initially, that is push back and lift, right, lift and insert the micro SIM card as is shown in this one. The notch should be this side, and next lock, push and lock, and then switch on the key. Wait till the particular SIM card get the signal. So that will be confirmed by calling to the SIM card, or else there will be one blue light will be blinks. I'll show you that it will blinks once it get the signal from the subscriber, right? You can see that one light is blinking under the GSM modem. I'll show you that. Right, okay. So there is a blinking confirmation from the GSM modem. For double confirmation, you can call to that. So now you can see the messages on the LCD. So I'm increasing the speed. Right, the vehicle is moving. maximum of 65 we set the speed limit in this one 60 kilometers per hour. So now in normal zone, so when it's trying to entering in that, just when I'm pressing this button, then we make the region surrounded by this RF transmitter as a school zone. So now it is going to the school zone now. You can see the zone is displayed on the LCD as school zone 1. As the limit is less, the speed limit is in under control only, then no need of any warning, but there is a light indication over here. So see, this is the light indication, normal, like this. And now so it is giving warning on the LCD to the driver like reduce the speed. After 5 warning consecutive messages, then it will send the message to the department person. Right, so we got the message alert. So called vehicle number crosses the speed limit at school zone. Right, so coming to this motherboard, so we are providing 12 volts input to this, and after this 7805 regulator we will get the 5 volts constant power supply, and that is the main operating voltage of the microcontroller and input output modules along with the GSM model and RF and LCD. So once the power supply is given to the microcontroller, so it start working by reading input from the RF and controlling the outputs along with the GSM, and this is the reset switch to restart the microcontroller. And next, another important component is crystal oscillator. This steel plated one is a crystal oscillator which will provide 20 megahertz clock frequency to the microcontroller. The main purpose of the oscillating frequency is we have provided the instructions in embedded C language. So based on the clock pulse, 1 clock pulse per instruction controller needed, so that we are providing 20 mega clock pulse, nothing but 20 megahertz clock frequency. So microcontroller can execute 20 mega instructions per second. Right.